Assalamualaikum warahmatullahi wabarakatuh. We are from KA05 and we are going to present to you about our final year project, which is the performance of grassroots in the stability of slope at the entrance of Pagoh. So now, this is the table content of this presentation. Okay, so first let me introduce to you our group members. The first one is the Muhammad MIFDHAL AKIF. Second is me, EZANI FIZAFARISHA binti KAMAL. Third is Muhammad Aiman JAMIAN. Okay, so now I'm gonna present to you about our introduction. Okay, so slope stability is the important element that have to take care to avoid something that unwanted events such as slope failure and soil erosion. Okay, so engineers have taken about few engineering techniques to stabilize slope, okay, such as soil nailing, rock bolting, retaining walls, and also such economic techniques, which is planting. Okay, so we focus on the Pagoh hubs entrance slopes. Okay, we observe the profiles, 7 slope profiles. Okay, that have mainly is from vertical cowgrass soils and unrooted soil. So we focus on the moisture content, plastic limit, and liquid limit, which is attribute limit. Okay, and soil particles distribution, density of soil, strength and shear stress, and specific gravity. Okay, and all the slope profiles and a few data were taken from the previous studies, which is estimate the stability of slopes at the entrance of Pagoh using geoslope software.
Hi and Assalamualaikum. My name is MIFDHAL ZAHIR and now I will be presenting the problem statement for our project. Now there are many types of plants used as natural slope stabilizers. Plant roots provide an additional cohesion to the soil and increase its strength. Different plants has its own unique root properties that behave distinctively in maintaining slope stability. Now, our goal is to find the differences in performance across several aspects between vetiver grass and cowgrass, the two most common grass found on slope at the entrance of Pagoh, and compare them to the unrooted slope. Next is the aim of the study is to determine the most suitable types of grass at maintaining slope stabilization at the entrance of Pagoh. Next is to analyze the different inability of vetiver grass and cowgrass to provide additional stability to the soil. And finally is to study the amount of water absorption for grassroots to increase its field capacity and reduce the soil erosion at the slopes of Pagoh. Now for the overview of materials and methods. Step 1, we conduct a literature review of slope stabilization. The next step is the preparation of grass samples and slope profile mapping. Step 3 is the lab test experiments, consists of 4 different types of experiments. Next is the geoslope software analysis, and finally the analysis of data gained by the experiments.
Hello, today I want to talk to you about the lab test that we do. The first lab test that we do is sieve analysis. The objective of sieve analysis is to determine the grain size distribution curve of soil sample by passing them through a stack of sieve decreasing mesh opening size. There are 5 procedures of this experiment. First, the sample is done using the oven, and then we need to weight the soil and measure. Second one is the sample is poured on the top sieve, and third, the stack of sieve is placed in the mechanical shaker and shake about 10 minutes. Number 4, the weight of soil retained in each sieve is measured and note the corresponding sieve mesh opening and number. And the last step is repeat the experiment at using different type of soil in different site.
So now I'm going to continue with method B, which is attribute limit. Okay, so attribute limit divided into 2, which is liquid limit and plastic limit. Okay, so for liquid limit test, we are going to water, add a minimum amount of water into the soil where the liquid state of the stone still remain. Okay, that's why we added a minimum amount, because we want to maintain the liquid state of the soil. Okay, this test have a small shearing strength against flow, and the soil behavior by carrying this test is gradually change from plastic to liquid state. Okay, so we are going to use coil penetration apparatus in this test to measure the soil penetration with different amount of water. Okay, we are going to take a few data to check the liquid state of the soil. Okay, and the graph will be plotted is average depth of penetration versus moisture content graph to define the liquid limit. Okay, so now I'm gonna talk about plastic limit test. Okay, so plastic limit test is defined as a moisture content where soil begins to have plastic behavior. Okay, yellow we have a liquid limit test where we just add a minimum amount of water because we want to remain the liquid state. But at the plastic limit test, we have a more amount of water because we want the soil to change to plastic behavior. Okay, so we will mold simple samples into a shape and it will retain that shape. Okay, and for a sample to be called solid or non-plasticity, the moisture content must be lower than the plastic limit. Okay, and this test also have help us to find the lowest moisture content where the plastic still behave as plasticity. Okay, so now we are gonna move to specific gravity. Okay, so for specific gravity test, we are gonna use pherometer to help us calculate the work ratio, degree of saturation, and others that related to specific gravity test. Normally, it have a specific gravity from 2.65 to 2.85. Okay, and a porous and organic material soil must have specific gravity greater than 3. And specific gravity is also defined as a ratio between unit masses of soil particles water.
And for the final experiment is the direct shear test. The purpose of direct shear test is to determine the shear strength of samples, cohesion, and the angle of friction. A shear test box in geotechnical lab is used to run this test for 6 rooted soil and 1 unrooted soil samples. The specimen have been cut off in dimension of 10 by 10 by 2.5 centimeters size and is run by software into the shear test apparatus. All the samples have been conducted under different compressive stresses of 1 kilogram, 2 kilogram, and 3 kilogram. Afterwards, the cohesion and friction angle value can be obtained by the graph and were ran in GeoSlope software to determine the safety factor.
So, this is the result that we obtained from SIF analysis test. We do 7 sites on this experiment. The first site is for cow grass, the second site is for vetiver grass, and the last site is for unrooted. From all this experiment, we can conclude that the soil characteristic at all sites are mostly well graded.
Okay, so now I'm gonna talk to you about the results of attribute limit test for vetiver, cow, and unrooted slope. Okay, so we have seven samples. S1, S3, and S5 is for cow grass, and S2, S4, and S6 is for vetiver grass, and S0 is for unrooted. And we will calculate the PL, the percentage of plasticity limit, the percentage of liquid limit, and the percentage of plasticity index. Okay, so this is one of the samples that we're gonna determine the liquid limit test, liquid limit percentage. Okay, so firstly you have to get the data, the table data for penetration and moisture content. Okay, after you put the graph, and you have to search as the 20 millimeter penetration. Okay, and from the graph you're gonna get the liquid limit which is 52.56. Okay, and yep, 52.56. Okay, for this is for S1 graph. Okay, and that's how we get the liquid limit. And for plasticity limit, we have to use formula to get the plasticity limit. Okay, and liquid limit, you have to minus liquid limit percentage with plasticity limit. Okay, when you minus with these two, you will get the plasticity index. For soil specific gravity, okay, so this is the result that we get, the final result. Okay, for S1, S2, and until S6 and S0. Okay, as you can see here, the specific gravity of the soil are within 2.65 and 2.85. This is from the laboratory test. Okay, this is the data that we get for S1, S3, and S5. So this is for the cow grass. And lastly, we have to calculate with the formula mass of soil particle divided by mass of an equal volume of water. Okay, S1, S3, and S5, which is cow grass, have a lower specific gravity rather than S2, S4, and S6, which is vetiver grass. Okay, you can see here that the vetiver grass have more specific gravity than cow grass, and of course the unroot is lower than the cow grass and the vetiver grass.
Now the results on analysis for the direct shear test. As you can see by the table, the cohesion of samples for all sites are vastly different based on the types of plants and the types of support. The most significant difference is when we compare the cohesion value between rooted slope and the unrooted slope. We can see that on average, the value of cohesion for rooted slopes are way higher than the unrooted slopes. This proves that the roots does provide additional strength to the slopes. It is also observed that the vetiver grass on average yields a higher cohesion and friction angle values than cowgrass and unrooted slopes. The angle of internal friction was obtained from shear stress versus normal stress diagram after the direct shear test. Finally, the value of cohesion, angle of friction, and gamma for each side was tabulated to run for a geoslope to get the safety factor of each slope. And now the results and analysis of geoslope software to gain the factor of safety. The value of cohesion, angle of friction, and gamma that has been calculated from each side were entered into geoslope. The slopes are found to be stable because the safety factor of all slopes is more than 1. The safety factor obtained is considered high due to the types of soil and the addition of roots that increases the strength of soil by a significant figure. The unrooted slope obtained the lowest safety factor value due to the lack of additional strengthening properties of grass roots. And the highest factor of safety value obtained is 89.284, obtained by slope 6, which is the vetiver grass slope. The lowest value is slope 7, which is the unrooted slope. And the factor of safety we obtained was 66.7. So that's all for me. Thank you very much.
As conclusion, we can conclude that different type of grass do have different performance in increasing the stability of slope. This difference can be determined by doing several experiments towards the sample that have been located from the slope near the entrance of EDU hub Pagoh. It was found that the safety factor of all the 7 slopes are in a very stable condition. The result obtained become more convincing and precise by the help of geoslope software, which determine the external and internal structure of slope in more detailed way. That's all from me and my group. I hope you guys enjoy our presentation and get some knowledge about our final year project.